Thank you for the introduction and good morning, everybody. It's a pleasure to join the webinar, and I had the honor to introduce some of the innovation projects done at SAPPI. I assume most of the participants for the webinar know SAPPI as a company. What I'm going to introduce today is a different side of SAPPI, where I'm going to focus on the biomaterials and how SAPPI how our view is to solve the sustainability and the future of our society. There's no question here as everybody is looking for a sustainable and scalable, responsible technologies and alternatives to replace so far the fossil-based solutions. And there's no question that it's extremely difficult to create solutions that are truly sustainable. And here at SAPPI, we took our approach to develop those solutions and to make it to a reality and to put into the practice. What I'm going to share with you today is our two cases actually developed at SAPPI. One case is branded as SAPPI Valida, and the other is SAPPI Symbio. I'm going to start with the first one. As you all know, that our main resource at SAPPI is actually our forest, so it's trees. And there are three key components from our resources. So every tree is composed by cellulose, hemicellulose, and lignin. Our aim is to utilize every single component from our trees. So from the cellulose, we can make paper and packaging, and that's our core business. We can also make composite, so we add cellulose into polymers. We make dissolving pulp for the textile industry. We make release papers, and we also make nanocellulose. Today, on my topic, what I mentioned just now, is going to be focusing on the fiber composite and the nanocellulose. From the hemicellulose, we can make sugars. This is actually a side stream from the pulping process. So we make C5 sugar, and the sugars are the natural components to build on for further production of different products, such as sweeteners, binders, resins, etc. And we also make use of our lignin. What you all know, SAPPI produces lignosulfonate. This is playing an important role in the construction field. We are actually one of the largest producer of lignosulfonate. Now we also developed new applications for our lignin product used in bindings, in surfactants, in plastics, etc. Now let's start from the first case, which is called Valida. Valida is a fibrillated cellulose. So I'm going to share with you a 1-minute video to give you an impression of what is Valida. I need some help from our colleague now to play that video.
Cellulose is the most abundant organic material on Earth and the main component
Okay, now we're back to the presentation. As you can see, Valida is totally natural. And there's no difference from the nature of the product. There's no difference with a normal pulp and Valida. What we do is we process the fiber to a smaller scale and it brings in a magic features which a normal pulp doesn't have. It is still renewable, it's not toxic, biodegradable, and biocompatible. Follows the general trend of different industries are following. As explained by the video, that by creating those little fibrils, we create a big fiber network. And this fiber network being dispersed in a system, either is an aqueous-based system or a solvent-based systems. This network works as a carrier to carry the system. And this can be a solid water system, can be an oil and water system, and the system becomes stable. We are not using a chemical-based surfactant to reach this stabilizing functionality. Instead, we use a renewable material, biodegradable material to contribute to this functionality. And to put into practice, what does this mean? I'm going to share with you a number of examples what Valida can do in a system. Here we start from a coating and paint system. Valida can do a lot. It's a multifunctional additive. And here I only show you one functionality, which is anti-sagging. Sagging is an issue, it's a known issue for the coating industry. Typically, people use thickeners to avoid the sagging issue. If you add Valida, you can clearly see that the sagging issue is totally solved. And actually, apart from the sagging, we can also contribute to anti-cracking, to sprayability, to the mechanical strength like the anti-scratch, etc. We have done a lot of research work to prove the value propositions. Now we are in a commercial phase. So Valida is actually used in the paint industry worldwide. Now, another example here how Valida could play in the packaging industry, especially those one-time use packaging material to replace currently the plastic packaging material. Valida is a natural barrier material with excellent grease and oil barrier and excellent oxygen barrier. Here, the results shown on the screen is a demonstration of the grease barrier performance. On the left side, you see a paper which is produced at the SAPPI. And in the circle, half of the circle on the left side is there's no coating. On the right side, we coat it with Valida only. And after that, we apply a mineral oil on top of the paper with the dye. Then the oil, if there's no barrier performance from the paper, the oil will penetrate, go through. If you turn the paper upside down from the back side, you will see it. The side without a coating layer, the oil went through, and the side with Valida, the oil has been blocked. This is a direct proof that Valida could contribute to the packaging. And this has been one of our key focusing areas. We expect to develop a 100% renewable and recyclable packaging material using Valida. Another example is personal care and home care. Being a natural material is very much welcomed in the industry. Valida could work as a stabilizer to stabilize pigments. For example, the sunscreen formulations. Because of the shear thinning behavior, we can enable spray. Meantime, we can stabilize the formulation with a natural feel. Compared to those sugar polymers which typically used in this type of applications. Very sticky, as probably you can recall with your own sunscreen. When you put on your arm or your face, you feel the stickiness. If you use Valida, that feeling definitely will be improved, and with also a very natural skin feel. I have to see that the cosmetics work, since we started about a year ago, we have received a tremendous amount of positive feedbacks. The business is also growing very fast. We see that the industry very much welcome a green a natural ingredient come from trees and replacing those fossil-based chemicals. Another example here is a lip gloss. You can see there are two lip gloss formulations. On the left side, you have the traditional solution using a modified cellulose, it's hydroxyethyl-cellulose. On the right side, you have Veleda. So Veleda brings in a natural body to the color, and the color becomes more intensive. It gives a nice appearance. This is also appreciated by the industry. We look really a big variety of applications. This can range from food, from agriculture, from concrete, adhesives, composites, etc. And we are trying to get Veleda ready for all these different applications. For food, for example, the FDA approval is going to arrive very soon. We will soon start the food development. And the other areas are all active. I'm very willing to share further information if some of the audience are interested to learn more details. Our aim is to develop Veleda as a sustainable solution for industrial applications and everyday products. Now, this page concludes the case for Veleda. From the next page on, I'm going to introduce you another exciting development at SAPPI, which is called SAPPI Symbio. And SAPPI Symbio is also a fiber-based product. The difference with Veleda is here we have a composite composition, which is wood-based fiber plus a polymer. Currently, we have commercialized our first generation, which is polypropylene. I'm going to share with you a second video. It's also a minute to give you an idea what Symbio can do and what is Symbio. Okay, now back to the presentation. I hope this gives you a kind of a concept of what Symbio is. After adding fiber into a polymer, and the Symbio material compared to the polymer alone, it brings in a natural feeling, a warm touch, and bring the additional mechanical property to the material. And be more specific, if the density goes down, we can contribute to the lightweight trend. Meantime, brings in the stiffness, and also lowers the process temperature, so improve the processability, and also improve the thermal stability of the material. I'm going to share with you some specific data in the following page. Where Symbio can be applied to, just as shown in the video, Symbio can find its application in almost every segment of our life, into furniture, high-end packaging, kitchenware, appliances, consumer electronics, and automotive. I'm going to share with you a bit more specific information in the automotive application. So what can Symbio do to the automotive industry? Obviously, the weight reduction. Right? In total, we can achieve 15% weight reduction. Meantime, because of the easy processability, we can achieve 20 to 40% cycle time reduction compared to the normal polymers. We can also improve the acoustic effect, improve the sound. I will show you some data later on. And there's no odor, no smell, and this has, of course, due to the natural feature of Symbio, we can contribute to a positive life cycle analysis. We can achieve up to 40% sustainable materials in the entire car. But where Symbio can be applied to in a car, as you can see from the graph, Symbio can be used in all instrumental panels, in door panels, central consoles, interior trims, etc. We have achieved a lot of progress recently in demonstrating the parts for automotive industry. Now, looking at the benefits of aiding Valida, first start from the sound reduction. Compared to ABS, compared to pure polypropylene, as you can see, the sound reduction for our different grades has definitely improved due to the acoustic effect. From the strength point of view, aiding fiber increased the tensile strength significantly. As you can see from the graph on the left side, the more fiber you put into the polymer, the tensile strength increase linearly. From the stability, especially temperature stability point of view, aiding Symbio also definitely improve the stability. Now, from anti-scratch resistance point of view, there's a clear difference. I show you here the comparison on the left side, which is the Symbio material, and on the right side is the reference case. You can see under the same testing protocols, we saw totally different results. The Symbio material is much more resistant to scratch. Now, what we are offering to the market today? So, first of all, we are offering a master batch solution, which has up to 60% fiber content, and our customers can use the master batch and easily dilute to a lower concentration depending on the application requirements. We also have ready-to-sell, ready-to-use grades, which is called PP20 and PP40, which contains 20 up to 40% fiber, which can be directly used, easily processable material for those extrusion and injection molding process. Right, this is my last page to conclude that we believe that the ideas and innovations spring from correlations of diverse perspectives. We are very open to invite partners to join us for co-development. Only by doing collaborations and being a partner, we believe that we could bring innovations to the society, to a society, more broad society, and to a practice. If you are interested in any of our innovation projects, not only the Valida and Symbio, please get in contact with SAPPI, and we are very much willing and happy to discuss further. Thank you very much.